Testing. 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 1, 2. Yeah, let's get started. Since you're all here. So let's quickly review what we have done on Monday, right? So the goal today is to finish this topic. Okay. Basically what we have covered today is a 2 sample test, but later you will see most of the procedure is similar to the one sample test. So basically just we are repeating but in a different formula. Okay. So I think it's good to take a look again on how we do different of tests, and then that will help us to I'm not going to review everything, but maybe I pick up some of the Z, some of the T, and then that's what we do. Okay. So let's review this question, which if you try to look at the assignment, then it's already very similar here. Okay. So the question given is that you are try to solve the problem of hypothesis testing, right? The idea is that you have some hypothesis or a claim, or we want to see if the population mean is equal to certain value, right? And that is the mu equal to 6 or mu bigger than 6. So that is the question. Okay. So that's a question. And what we know by the normal assumption, right? We know that X bar, right, will follow a bell curve, right? And according to the null hypothesis, mu is 6, right? And our alternative hypothesis that mu is bigger than 6, right? So we have to decide based on our sample result, okay, what we got in sample, do we favor the idea mu is equal to 6 or mu is bigger than 6, right? So that means that we would be thinking the idea that if it is big enough from 6, right, then we would actually prefer mu1, right? If it's close to 6 or even below 6, we would say X null or X0, right? That is the idea, right? It's big enough. And how to quantify this is big enough, right? The idea is if this is big enough, it represents the idea that this area, right? Because it's the further away, the area is small because this probability, right? It's very unlikely to happen, right? If this is 6, right? That means that if this area, the orange area, is sufficiently small, then we would say it's far away, right? And we refer this probability as alpha, and turn out this alpha is indeed what we call type 1 error, right? Type 1 error is assuming H null is correct, what is probability that mu will reject, right? So this is exactly the alpha, and you control it. So remember, alpha is 1%, 5%, or 10% in general cases, right? And usually how we do it, right? In this particular case, we know the shape, right? Because we know sigma square, we know n, right? How fat is this is exactly we know, right? Actually, we exactly know this number is indeed 6 plus minus, 6 plus z alpha sigma over root n, right? We know this number, right? And indeed, The idea is that if X bar is more than this number, then you reject. Otherwise, you don't, right? We know it, right? But do remember, this is usually what we don't do directly. Usually what we do is convert it to the Z space, right? And once you convert to Z, right, this becomes 0, and this value is set alpha, right? For this to be alpha, right? Okay. And you just check if your value is in this green region or not, right? Or that will be the critical value method. Or you can do the p-value method, right? You calculate based on your number, which is 2, right? You try to check the p-value method will be the same, but you look at the Z, right? 0 is here, right? You look at the 2, right? Where 2 is, come from 7, right? Because your data is 7, right? 7 is 1 away from 6, and the SD is half. So the distance, right, actually is 2, right? 2 SD. And we're asking this area, all right? And this area turned out to be 2%, right? So you would reject at 5%. If you use 1%, you don't. 10% you do, right? So one way or the other, we know how to do. Okay, let's review another question of a two-sided test on T. Okay, let's do another one so that we know what we're doing. Okay, let's do the left-hand side T test. Okay, I'll do this one. Okay, and the question here is I want to test this hypothesis, right? We want to see if we want to use the data, if the data is supporting the x0 or x1, right? Whether mu is 4 or mu less than 4, all right? To remind you why we do that, right? I think easiest to get my drink here, right? This is the low sugar drink, right? So you want to see if it's actually low sugar, right? Something like that, right? Because you want to see if they're not, they probably don't want to drink, right? So it really depends on what you want to do. So again, we can draw the graph. As I recommend, it's easier to draw the graph than remember the formula. Okay. So I have X bar here. Okay. And the question that is given to us is saying the population follow the normal, right? That means that if you do a sample, random sample, this is also normal, right? We know that, right? And we know, if we know the sigma, right? This will be sigma squared over n, right? The variance, okay? And where it should be is unbiased, right? So this X bar will be actually 4, right? Under this, okay? Assuming the H0 is true, H is 4, okay? And the idea that is, okay, the data we have is turn out to be 3, okay? So it's here. The question would be, given that it's 3, do you want to say x0, x1? Look at the question is like that, right? You want to say 3, is evidence is going to say we should remain at x0 or which x1, x1, okay? And the question again is it low enough, right? It's low enough, right? And the way we set low enough is the probability, right? So we want to know if this probability is small enough, okay? And of course, if you know the sigma square, right, we have n here, right, sigma square, if you know, then it's easy, same as the Z test. The question is you don't know sigma square, okay? And how can we figure out this probability here, right? It's not that easy, okay? But turn out to be, luckily, we know that although it's not a bell curve, we know there's another bell you can check. It's called a T-bell, right? A much fatter bell to check, right? Because even though we don't use it, right? And we use the other one, we use the S square, right? And we do that, then we still can have it, okay? That would be T table. Okay. It is again 0 here, okay? And how to convert 3 to here, right? Remember the same formula, right? Except that now this is S. Okay, so that is the main difference between Z and sigma, is whether you know the population standard deviation, okay, or population variance. Okay, if you don't know, rely on this. Of course, in application, most of the time you don't know, so this is the standard procedure you would do, right? Because you never know, okay, unless you have good knowledge about it. Okay, otherwise this is the case. Okay, and turn out this -2. Okay, and again the question will be, this area will be same as the above, right? And you just need to calculate this area, right? And in this particular case, maybe worth to repeat the Excel formula, right? This is T is which T you're using, use 15, right? Because you use the n-1, okay? So from number to area on the left, just T this, right? Right, distribution function is F, right? It's an F function. -2, right? And use the 15th one and 2. Okay, so this will give us the area, turn out to be 3%. Okay, then yes, the question. Oh, because this is always positive. So the way we denote that is the this alpha. Okay, let me show. So the question is why I have a negative, because this, the notation we have, means P15. This is 0.05. Okay, so it's the right tail area. The right tail area, this is positive. Is that correct? Yeah. Yes. Yes. So you asked me why I do that. I think I follow textbook, so that is pretty much the notation is the key alpha is the positive area, right? Because is that okay? Okay. Yeah, that's pretty much what I want to say. Okay, for the T. Is there any question before we proceed? Okay. If no, then I do another two-sided Z test that talk about proportion. Okay. Then probably you would be okay. Is that okay? No more question? Okay. So we will do the proportion one. Okay. And I want to remind you that proportion, in the example, I don't have two-sided. Okay. But the one side is same. Okay. You do apply the same technique, but to save our space, I just do one. Okay. I just do the two-sided. Okay. So the only thing you have to remember is for proportion, the formula, because the mean and the variance are related, so that's why the formula is like that. Okay. And you can remember, right? This is exactly the part that you do confidence interval. So that's not something terribly complicated. Now let's go to this example again, right? Remember the motivation for this is the gender ratio, right? In the school, right? And we know it's 40% of the student in undergrad in B school are male, right? And 60 are female. And we will try to test it, right? And test it turned out to be half of them are male and female. And then we have sample size of 50. And we want to see if this is going to change our perception. Is it going to be 40% of them are male or not? Okay, that's a question. Okay, so remember when we have proportion, it's always normal. So that means that our life is easier. P. Okay. Okay. And this is 0.4 here. Okay. And we want to see this is going to be different from 0.4, right? So that means that if it is too large from 0.4 and too little from 0.4, then you should favor X1, right? So the idea is we're expecting ourselves, if somewhere here onward, right? And somewhere onward, then we would be in favor of X1 compared to X0, right? And the question is how to decide how extreme is extreme, right? And we use the same idea, use alpha idea. And we decide alpha is a type 1 error, right? Because even this is correct, and up here it's possible, right? So we would say it would determine, because we don't know where it should be, so we pick alpha over 2 on the both sides, right? Do note that when I have proportion, when I know the mean, I know the variance already, right? The variance will be just given by 0.4, 1 minus 0.4 over n, right? So the interesting part is the most important part as well is the proportion is you know the variance, right? If I know the mean, I know the variance because that is given by the particular formula here, right? Just 0.4. That is, if we call ourselves the binomial, that is what it is, right? The mean and variance are related. Okay. And now what we have is, I said, is 0.5. Okay, maybe somewhere here. Okay, can be somewhere inside or not, but I don't know. Maybe here actually, or actually inside the blue region. But turn out it's like this. But the question is, you want to see, is it far enough, right? Is it within, right? So we know it's bell curve. That is very simple, right? So basically, we just convert that from P to the Z space. That's with the color. Okay. Red. I don't know. Red. Okay. To the Z, right? And this is 0. Right? And we look 0.5 is what? You just do this calculation, right? You just minus the mean over the SD. It's 1.44. Right? So the question would be, is this area times 2 bigger than alpha or no? Why times 2? Because it's alpha over 2. Right? So you compare this with that, right? So how can we calculate this Excel function? Okay. This is area on the left. Is subtract from that, we get area on the right, right? Because area on the right here. So area on the left will be norm as this 1.44, right? This is area on the left, and on the right, 1 minus, right? And then you multiply by 2 because you compare it with alpha over 2, right? Just to recall what is p-value. P-value is just, you adjust the alpha such that this is just reject, right? So that is the meaning. That's why you multiply by 2. Okay. So I guess I reviewed 3 important formulas, 3 situations. Today, if you go home, you try to work out your assignment to see whether you get it or not. Shouldn't be difficult, but should make yourself comfortable with that. As I said, our final test is not complicated. Should be, I would consider easy, but the thing is how fast you can do it. Okay, it's a need for speed. Okay, but it's not really something complicated. Okay, because if I give you 3 hours, everyone can get full mark for sure. So that's why the only thing is how fast you apply. I mean, if you understand, you apply quickly, then you shouldn't be. Means that you do a normal speed, right? Rather than if you read the question, you need to figure out which formula to apply, then probably you are not able to finish all questions. But don't worry. In general, so you are able to do the assignment, you understand, you attend the lecture, you do it, you're able to understand how assignment being done. Usually, I mean, it should be the A range, right? I mean, with the A and A minus, depend on your project or other thing as well, but you should be fine, okay? And other things will get B, right? I mean, so, but I guess shouldn't be a big deal, okay? Is that okay? Now, okay, 2 samples. Is there any question? So here, you may see I just only give formulas, okay? So slightly boring. I'm going to try to work out the example with you, but from now on, I mean, most likely, basically you learn basically all the math we need for this class. From now on, it's just applying what we have learned. So not really new thing, but just tell you, okay, under this situation, how we apply what we know. And unfortunately, as you may see, it's not too much thing to explain, but rather formula, boring from applying. Okay. But since we to learn, so I want to go to example carefully. If you have a question, please ask, because you basically learn everything what we need for the whole class, whole course. But anyway, let's go. Okay. So basically, what we do is extend what we learn from 1 sample to 2 sample, and the logic is very similar. Okay, so you don't need to worry too much. Okay, and of course, in the exam, probably you have to distinguish different cases. Okay, by reading the question, if you understand, that is shouldn't be an issue. But let me give you the idea behind what we are doing. Okay, and so far we focus on one population. Okay, it means that we think the whole population is the same, right? So suppose, remember, the leading example is Elon Musk want to sell his new phone to China, right? If you think China is a whole country, as a whole single market, then you're done, no problem. But if you think people across the Yangtze River is different from the north and south is different, then you consider 2 different markets. Or in China, you consider male or female different, then will be different market, right? So that we call independent population, okay? And each population have different mean and different variance, okay? Independent means that whenever you get from the first population, different from the second, okay? There's no indication, okay? And some notation here is observation from population 1 will be 1, 1 and 1, 2, right? The first subscript is represented population, right? Which one you're looking at, and 1 is the subjects that you're looking at. Okay, so that is a notation. But don't worry, just a bit notation, right? May suppose 1 and 2 are female and male, right? So this is the first lady, second lady, third lady, the n1th lady, right? And 2 is male. This is the first male, second male, third male, last male. Okay, that's it. Okay, just notation 1. Okay, nothing deep here. And of course, we can calculate the average for the female, average for the male, right? And because the unbiased and random sample, the property of the mean and sample mean and sample variance are there, right? The same thing. Okay, nothing very deep here, so just list them out. Okay, and of course, you can do the sample variance, right? Each part, and do note that is n1 minus 1, right? Because sample variance is minus 1. So nothing. Still, everything is very straightforward. Nothing new here except the fact that the notation have to be a little bit. You have to remember what it is, right? For me, it's very natural, but for you, when first time seeing this, is kind of unsure what's going on. Okay, but it's very normal because the first time you would feel confused what it is. Okay, but I try to explain one by one, which is the same, right? It's if you look at a female, right? Look at every observation minus the mean of the female I take a square over how many female there. That's a standard thing there. Okay. So what we assume is we assume the underlying population is normal, okay, and the sample mean also normal, so the bell curve. So then now what we have simply means instead of single bell, we have 2 bells. Okay, that's what we're saying. Now what we want is to compare the difference, and why we want to compare difference, right? That is supposed to want to Elon Musk, you work for Elon Musk, right? He's trying to sell the phone in China, right? And you know, different color can maybe sell different price, right? Even imagine their car, right? The Tesla, the car, right? If the car is a black color or white color, right? Can be different from the price for the red color car, right? So you can charge more, right? And the question is, are they willing to pay more, right? You want to see if willing to pay for a red car is different from female compared to male, right? If that's the case, if female willing to pay more for the red color car, you can charge more. Is there no difference? You don't, right? It's very applied question, right? Or you want to say, is there a difference between 2 warehouses? You do audit, right? You want to see if actually there are some difference between different locations, right? So on and so forth. There are many things you can do. You need the difference. So under the independence population, the difference, remember the formula we said when we talk about random variable, right? Difference between bell is still a bell. So this is where we use here, right? Recall difference here. If you forget, doesn't matter. Let's go back to this slide here. Actually, we mentioned it a little bit at the very middle, right? If you at the very end of this class is this graph. Okay, we said this, right? There's 2 bell. The difference is still a bell. Okay, the mean of course different, the variance add up. Okay, so this is the property that we use here. Okay, that's why I put it at the beginning, as I said, right? Nothing is new come from this class, just applying what we have learned. Okay, so basically you don't want to worry, just there's no new thing, we're just combining different old things that we have learned. Okay, so of course it's still new, right? Combining new things, old things still can be new, but shouldn't be too surprising for you up until here. Okay, now as we said, what application, right? Is managers store A better than store B. If the case, probably you want to give more bonus, right? Or you want to increase your sales and look at why store B is worse than store A, right? If you're marketing manager, right? If is product A sell better for B, right? Or you consider a band, I think in Hong Kong, Mirror, right? You have many people there, right? You want to see who is more popular, right? If more popular, then put it upper court, right? And then not so good, put in the lower court, so on and so forth. I don't know much about that, but I guess that's it, right? And science, right? Is vaccine A better than vaccine B, right? If the case, then you want to do it, right? Or this mass is very useful, right? 2 group of people, 1 group of mass, 1 group of no mass, right? There are many things you want to, there are a lot of time you want to compare stuff, right? So that is the way we do, okay? Okay, so let's focus on the easiest case first. There's 2 cases here. One is we make a specific assumption saying that they have equal variance. Okay, you assume that, say, the boys and girls are no difference. Okay, you can imagine, you can believe that, or you think that people in Hong Kong is not different from, in terms of variance, to not be different from New Territories or Kowloon Peninsula, right? If you believe so, then we don't prove it. Actually, they prove here the total variance, okay, can be estimated by this, okay? What it is what is the poor variance is, if the same, we want to estimate what the sigma is, okay? Remember, let me draw a picture here, maybe easier. Okay, so what we have now is, we're a bunch of guys, okay, and bunch of ladies, okay. We want to ask them, okay, how much they're willing to pay for the product, right? We're going to see whether different or not, right? So the question would be, the simplest case is, okay, according to this, there's a bell curve, right? How much they pay, right? And we assume it, the easiest case, they have the same shape, same sigma, right? And for the female, there was have another, they have their mean, right? And for the male, also bell curve, the same shape, okay, same sigma. And this is a mu m, right? You can use 1 or 2, doesn't make a difference, okay? So the question we're asking is, okay, from the data, right? Collect some data here, right? We can have mean of the male, right? We can have standard sample variance of male, right? And we also because we also get some female here, right? And we can also come up with sample mean for the female, standard sample sample variance for the female, right? And if you want to compare these two, right? At the end of the day, we want to look at mu m is the same as mu f, right? If the same, then you don't need separate marketing strategy, right? They're different, then you do. So what we're going to see is they're the same. How can we estimate this sigma, right? We have two different estimates, right? One is SM, one is SF, right? They are good estimate for sigma, right? Because as we assume they are sigma, right? This estimate sigma, this also, right? So is there any way to combine the two such that you get a better estimate? Okay, both are unbiased estimate. Okay, the question is who is more efficient? What's more efficient, right? So that means that you can actually turn out to be, you have to find some way to combine the two of them. Okay, and how to combine? Of course, you would think very naturally, depends on the sample size. All right, if in your sample you have more female than male, right? You want to prefer your answer closer to this one compared to this one, right? So that comes the formula that I gave there. Okay, the one we gave there is the most efficient one. Is you combine these two together to estimate sigma. Okay, I'm not going to prove it, but that's the idea that what we're doing there, right? You combine it in certain way, right? This proportional to n1, this proportional n2, right? It's a fraction. Right? The same thing here, right? It's compare n minus 1, right? Do you see that? So it's a fraction. This carry this weight, and how many people here, right? And this have this weight, right? So this is this between 0 and 1, this between 0 and 1, this up to 1, right? Just say mix it, right? Proportion, right? If n1 is equal to n2, 1/2, 1/2. Can you see that, right? The more n1, then you're weighting more this one here. Just weight it, right? Because both this and this are unbiased estimator for sigma, right? But we want the most efficient one, and this most efficient. I'm not going to prove it. Okay, the proof is there, but I'm not going to talk about it. We take it as a skip, okay? Because in your textbook, never prove, okay? So I'm not going to bother with that, right? Even a textbook doesn't exist, right? I mean, if you pick up the textbook that are used by other class as well, they're not proof. This is the formula, okay? Then you can use it, okay? So why we need that, right? Because here, if they're the same, right? You can forget about it, right? So you know the shape. So let me go to the example, then you will probably know what we're doing. Let me go to this example, okay? So that would be not that difficult, okay? So the example is following. I want to test hypothesis that the two groups are the same mean, right? And the same, that means that the difference between the sample mean, we have 0 mean, and the variance given by that under equal variance. Okay, you can use this formula, then we're done. Okay, let me go to the example, then let's actually do that part, then you will understand what's going on there. Okay, so let's see the example. How do we proceed? Okay, so now we have same, we have boy and girl, two population, they follow normal, have same variance. Okay, and we do this first sample is n1 is 50, x1 is 40, and s1 is 4. Another one is 40, 42, and 3. Okay, so let's write down in the whiteboard, and probably would help because there are a lot of information goes on here. Okay, let us try to do that. Okay, now let's do the boy and girl story again. So we have a boy here with n1 is 50, right? Because there are 50 boys here, and x1 bar is 40, and s1 is 4. Okay, this is the boy. Look at girl, n2 is 40, okay, x2 is 42, and s2 is 3. Okay, so remember they're normal, right? And the question is we want to see if they're equal or not equal, right? X now is mu1 equal to mu2, and x1 is mu1 not equal to mu2. Okay, I just do two-sided here, one-sided the same. Okay, but I just do that. Okay, so what does that mean? First, let us draw the graph first. I mean to understand this question, and we can go to calculation. Okay, so the question is like this. Now we assume that sigma 1 is equal to sigma 2. Sigma, all right? So this is the assumption, equal variance. Okay, we'll talk about unequal variance after the break. Okay, so the idea is very simple, right? We have a bell curve. Okay, both have the same shape, right? So the boy may be here. Okay, the girl may be here. I don't know, maybe there. I don't know where they are. Okay, and the question would be, okay, we want to see actually this data we're going to draw is going to support this. Okay, and remember what we are saying now is they have no difference. They're the same. Okay, so when you look at the difference, which is x1 bar minus x2 bar, will be centered at 0, right? Because under this, actually they locate the same location, right? So the difference, the two bell will be a bell again, right? Located here, right? And the variance according to the formula will be sigma square over n1 plus sigma square over n2, right? Right? So that is because you add up the two variance, right? Because this variance, because the variance of the blue, right, is sigma square over n1, right? And the red one will be sigma square over n2, right? So you combine them, just add them, the formula, right? Remember difference? You just difference the mean, sum of the variance, right? Just add them up. Okay. Now, if you know the sigma, it's normal. It's normal, right? It's a pair. So if you know the sigma, then we can do the Z test. That is nothing new there, right? But assume we don't know, more general case, we do the t-test, right? And we do a t-test, we have to estimate this guy replaced by the sample with the formula we give you. Okay, so that means that instead of doing this, we do this, right? We do the tag, we do the t here. Okay, so let us look at the data what we have. Okay, we draw a graph. Okay, what we are told that x1 is 40, x2 is 42, right? So x1 minus x2 is actually -2. Is that clear? because the question is x1 is 40, x2 is 42, right? So x1 minus x2 is 42. That's our data. Okay. Is that clear? So this is our data. Tell us. The question is it far away enough? Right? From now on, it's very similar to what we have done, right? Is it far away enough? Right? Because two-sided test, right? So what we're looking at is looking at here, alpha for 2, right? Alpha for 2 here, right? That is the same technique. Or you calculate the area on the left of 2, negative 2, and multiply by 2, right? That is it. We do it many times already. Okay. The only difficult part is which bell curve looking at. Okay. Turn out to be, if you follow the formula to estimate this, okay, the one is very simple. It just, unsurprisingly, it just n1 plus n2 minus 2. Okay. So that is the thing you need to know. This is the only difficult part. Other than that, same. Okay. So now how to convert negative 2 to here, right? What is the, how to convert it to here, right? What is the number here? Negative 2 to what? Okay. How to convert this number, right? You have to determine by this SD, right? Okay. So that would be negative 2 over the square root of the SP over N1 plus SP over N2, right? What's SP? Remember, SP is the fraction thing, right? SP is SP square is N1 minus 1, right? N1 minus 1 plus N2 minus 1, S1 square, right? And the same S2 minus 1, N1 plus N2 minus 2, right? S2 square, right? So that is the formula there. Okay. I'll go, I mean, everything in your slide already. Okay. Don't worry about that. Okay. But now I just give the idea. Now we go to calculation. Okay. I just give you the idea. Now we go to calculation. Okay. Now, the first thing to do is to calculate our estimated sigma. Okay. Which is given by this formula. I tell you what is what here. Right. So just apply the formula there, right? It's N1, right? Right, the formula N1, right? 50. And N2 is here, right? 40. Right? And this is S1. Okay. And this is S2. Why? Recall the formula is N1, right? Minus 1, N1 minus 1 plus N2 minus 1, S1 square plus N2 minus 1, N1 minus 1 plus N2 minus 1, S2 square. Okay. So we can just plug in, give you the estimate of the overall variance, right? So there's nothing deep from the, it's just direct up here, right? Cover this guy. Okay, that's it. Now, once you do that, then actually everything is become very straightforward because there's nothing new there. Once of this guy, right? Because once of this guy, then thing is the same. What we're doing here, right, is look at the difference, right? Because you care about difference, right? You don't care about the sample mean of 1. You care about difference of the mean, right? Different mean negative 2, right? You minus 0 and over this guy, right? This is the SP square, right? And you put it there, right? So just to recall the formula here, right? This is the SP square, right? And this is N1, right? And this N2. Right? Calculate this is negative 2.625, right? So basically, let's go back to the here, right? Simply mean this negative 2 here convert to negative 2.625. Okay. We want to calculate, we want to see this area, right? Multiply by 2 is then this is the p-value, right? Either use critical value or the p-value we find. Okay. Let us show you the final calculation because there's nothing new here. Okay. This number here, right? Just draw the diagram again. This is t, right? It's n1 plus n2 minus 2, right? Actually, this is 88, right? Because this is one is 50, one is 40, right? 90 minus 2 is 88, right? And the way we figure out 0 here, this is negative 2.625. So this area, okay? We want this area. P-value method will tell us calculate this area, multiply 2 is our p-value. We compare with our alpha, right? The same technique we have been using, okay? So as I said, we're very similar. Just a slightly twist of what we're doing in the denominator mainly, right? So this is just t, this, right? Negative 2.625, 88. Okay. Because error on the left, this is the formula, right? Not the right. Remember, multiply by 2 for p-value, right? Because it's a two-sided test. We compare this to alpha, then we decide to reject or not. Turn out that this is 1%. Okay. Same thing. Okay. Is that okay? Or if you want to calculate critical value, the same thing. I'm not going to repeat that part, but that should be not an issue. Okay. So lastly, before the break, I want to mention about estimation, right? A two sample problem. For estimation, you can also do the same, right? You take the numerator, right? And plus the denominator, right? And plus minus the critical value. How to figure this out? This is this guy, right? Remember, because two-sided test, right? This guy, right, is t 88, right? 0.025, right? Because you're looking at 95% confidence, right? So you want 95 here, right? So that means that you want 2.5 on the other side, right? And you can look at that is 97.5, right? So how to figure out this number, right? If you look at the Excel, right? This number comes from T inverse, right? For 975, 88, right? Because 95 is here, right? Then this is 2.5, so 97.5, right? So that's what we do. Okay. And this give us the confidence interval for a difference. Okay. So this is just the formula. The same as what we have applied all the times already, right? Because it's the same, right? Because this is a normal, right? This is a bell, right? This is the number, use the critical value times the denominator, right? This is exactly what we do when we do the interval estimation. Okay. So same as what we have done. Okay. And do note that this is two-sided, so that's why the critical value will be same as what we do confidence interval, right? Because 95 is inside. Okay. So I'm sure that some of you may still have confusion. So let's have a break, and I will answer you individually because I'm pretty sure there's not something easy. Okay. Let me open the U-Reply so that if you question, you can tell me. Okay. I go around to answer question you might have because probably you need it. So go around to see if any question, please ask. Samples that go in one. here. Same as that, it's more. Yeah, this is same. This is same as this. That's how you solve absolute inequality. I don't want to emphasize it. So here they might have dependent to go on one for one second. Suppose that we have one dependent. I don't know. And then the weather would get and help. Knowing anything. So whenever you take a very oil, you get the oil. Not all the variance, we assume that the amount of it from our that's why I want to that there's a some technical 一对的。看看。 So many of you, because the assignment is going to due, so have a question on assignment. So I recommend you ask the TA, because TA will be, as I said, it's not that I don't want to answer, because but the thing is to be more fair. So for the assignment that haven't been deadline, so please ask TA. So because to be fair, okay. But of course, after the assignment is over, then you can ask me or TA. That's not. But I recommend you ask TA because many people ask him already. So he is much more well experienced than I do, because he keep answering the same question again and again. So he know how to do it. Okay. So let's see what you think. How can we find T instead of Excel? Actually, most likely we use Excel to do our work. We just use T table because of our class, right? Our class. And I'm pretty sure I don't ask. Yeah, let me check with TA again. I never do. I would not ask p-value. The case that you need to use calculator. So, I mean, I would probably not ask in the exam, right? I don't ask the p-value for T, right? Because you can't really do it, right? But assignment you need to do it, right? But for the thing is not. So we would illustrate it again. In the next test we do, we will illustrate again. Okay, hopefully. Oh. So how to do? Okay, this is a very good question. So I immediately tell you, how do we find this value from the Excel? T table, it depends on what T table. Usually you don't have this particular TA. You have FT, right? You don't have a TA. But how do you do Excel? Yes, you have to find Excel. But you can find it from T table if FT. So let me illustrate a little bit how we do that from the T table, because I think that may be more clear. So the T table we have is here. Chapter 4, when we mentioned, oh, sorry, if chapter 3, no, chapter 4, chapter 4. The T table is here. Okay. And the question now is we don't have we don't find ATA, but the problem is we don't have ATA, right? The FTA. The best thing you have is 80. Okay? You can 80 or 90, but usually the convention you pick the smaller one, right? And we're doing two-tailed tests, right? The question was, right? Two-tailed test, right? 95 is in the middle. 95.95, right? And remember the table showing between these two numbers is 1 minus alpha, right? So that means that 1 minus alpha is 0.95. Alpha is 5%, right? This guy. So this is number that we'll pick. Is that okay? So that's how I do it. But of course, this is slightly larger, but this is what we do. Is that okay? Where am I? Okay. So how it's very similar to the number, right? 1.899, 1.897. Then the one we have is slightly bigger, but usually we are not just so close, so it shouldn't be an issue, right? And that's very close, but you know where it is. Let's go back to here. I hope, and probably you want to ask Excel, right? Excel is not that difficult, right? Excel is just if you want to figure this number out, right? With the area, we found this guy, right? So basically, it just T this, sorry, T norm because T inverse because of the right, and this is 0.025, right? This is 0.025, right? So this 0.975 ATA. That gives you the same number there. Okay, is that okay? I hope that is clear. Of course, you know you don't know when you do the assignment. Okay, then you go back and check. Okay. And in case you find typo in my lecture notes, then let me know. Please message me, email me so that I can check there's an issue because always there's some issue typo here again. The question should not be a problem, but okay. So when to use Z1 to use this, very simple. If we know population variance, Z, right? Because we don't need to go further. But if you don't know population variance sigma, we use the sample variance, right? S to do it, right? There is T. That is only difference. Right? We know sigma, Z. We don't know sigma, T. That is very simple. And as we know, most of the time we don't know sigma, right? That means that in general, in your application, most of the time you just use T. Okay. And probably some of you ask, okay, why we teach Z? Okay. The question is, when N is big enough, Z is enough, right? And in general, in business application, you would use when you have large sample, then Z is doable, right? You don't need to check a complicated table, right? And we learn something easier first, right? Before we learn something difficult, right? So that's the reason. I hope I convince you that why we do that. Okay, I'm glad that you asked this question because you should ask question because right? I remember the other group yesterday, right? He mentioned in this saying, "Oh, I borrow money to pay the tuition. I have to work hard to pay for the loan, right? So I assume some of you may be very rich, but some of you have to borrow to study. So please ask questions. Otherwise, you don't learn. You don't learn, then it's not very useful, very helpful, right? Because as a teacher, we try to help you, right? Our TA is very friendly. So I mean, although I'm very busy, but I try to help you as well. Right? But our TA is very specialized to help you. So please do ask for help from TA or actually ask for a classmate help. Okay, good. Today everyone knows today is Thursday. Yeah. So you can pretty much see people perception always from many of the example. We never have consensus even, right? For this one, right? But everyone think today is windy. Is that windy? not sure, but I don't know. I stay in the office, so I don't know. So I just don't know everything outside the office. Yeah, the key point is math. Kind of the case. As I said, this remaining is like applying formula. I don't know how to explain without going to the math, because this is, but the thing is, you understand what we're doing, right? The idea is with two samples, we want to compare that the same or not, sample mean, because that's very useful technique to compare and where apply. Okay. For example, right, you want to see the sales of this lemon tea, right, compared to the lemon tea without low sugar, normal one, right? You want to see which one to sell more, right? You want to put a space on the vending machine, which one to put more, right? Then you look at the sales, right? Look at the difference. So it's very important. Yeah, pull the variance and the equal variance. And actually, if you learn in high school, you learn statistics, it's already, this is the part that probably you last learned. Okay, you also learn that as well. Yes, very important. If the two side, you want to find the p-value multiplied by 2. That's an important note to remember. Yeah, converter interval estimator. Okay, and probably at now you will will see how two-sided tests and confidence interval estimation are the same, right? Exactly, you almost calculate the same thing. Okay, hopefully so the speed is a little bit okay. Yeah, I'm sure that it's not easy to follow because when I learned this, I find it very confusing. Okay, I only learn it because I go home and do some exercise. Okay, so it's not that easy. I have to admit, because as because there are too many things and it's not that easy. Today's topic is actually, yes, it's very difficult. But it's a lot of formula and a lot of notation. It's not that easy. Okay, I try to slow down a little bit. Why always type, even though, oh, that's very simple. The question is, you are stressed. Okay, if you're happy, you never think of this problem. Your man is a lot of mental mental thing, and also yeah, it's a mental thing. Can I talk about the rejecting critical value? Okay, is it all 5%? Okay, whether you reject or not reject 5% is your decision. That's a type 1 error. You decide yourself. 5% is general recommended for most purpose. Okay, you can use 1% or 10%. Either way would work. Okay, but remember, there's a cost of doing it, right? By choosing lower alpha, you increase type 2 error, which is beta, which we don't know how to calculate, but there's a trade-off behind. Okay, we don't tell you the detail, but the convention now is use 5% to reject. Okay, and rejecting critical value is like the case. Remember, let's try to draw a graph here. Okay, we have an X bar, right? And suppose hypothesis mu is here, right? We are rejecting on the right. Suppose H1 is mu bigger than A, right? This is A here, right? And it's large enough, we reject, right? That means that when we are thinking about this area is alpha, implicitly we fix the critical value. Where if beyond you reject, right? That is how they're related, right? Because the smaller the alpha, right, the larger the critical value is, right? So there we once you choose alpha, critical value, right? Because critical value decide when you reject, right? Because critical value is the value that is, say, this is too large, you reject, right? And how you determine the critical value is the alpha, right? Which is the standardized level, right? Usually 5%. Okay, I may ask 1%, I may ask 10%. Okay, in the exam. Okay, actually, I make this exam last night, so I may change. Now the TA is working on it to see if it's too difficult or too hard. But, He will tell me whether I need to make it easier. But do know that I'm not just asked 5%, okay? It may be 10, it may be 1, okay? Check carefully when you work on it. Okay. Okay. So now I go to the next one. So I maybe go slowly. It's a lot of stuff. Okay. So it goes a little bit slower, but that comes to a cost, right? If I go too slow, then we're unable to finish many things because I expect this just formula. So I'm not. In the past, I don't cover that so slow, but I try to slow a little bit. Okay. But okay, if I go too slow, I miss something, then I'll just cut them out from the test. So don't worry about it. So you slow me down, maybe little bit beneficial because I have to cut something from the exam. But it's okay. As long as the important is I cover a lot of stuff. It's important you understand what's going on. If I teach, I teach a lot, you understand, there's no point, right? So let me do it slowly again, slightly different, but hopefully you would be okay with that. So let us go to other test today. That will be similar, but now I don't have equal variance. It's unequal. Okay, let me draw a picture again to make sure that you see what's going on here. Okay, let me do it again. So now I have a bunch of boys. Okay, the question, a bunch of boys, very general. Okay, I want to ask how much they want to pay for a new product. Okay, and so it means that I assume they follow a bell curve. How much they want to pay a bell curve, right? The bell will have the mean. We call mu1, say this is group 1, right? And the variance sigma square 1, right? So that is simple, right? I have another set of people, they're all girls. Okay. And this is called group 2. Again, how much I want to pay is follow a bell curve. Okay, that's my assumption here. Mu1 is mu2. Because group 2, right? So I hope you now know the setting, right? We are looking at two groups of people. Okay. The overreaching idea is I want to test one thing. Do we have the boy and the girl want to spend the same? Okay. Why want to test it? If they're different, you want different marketing strategy, right? You want different way to handle it, right? Or if they want to pay different, right? You want to make the product, right? Boys, different color. Girl, different shape or different color as well, right? Make it more cheeky, make it more fun, right? So the question we're looking at is this they're the same? Or they're not? Okay, so this is the question. Is that clear to set out? Again, the same. Now we no longer assume sigma 1 square is equal to sigma 2 square. Not the same. Okay. Before we assume the same shape. Now they're not the same shape. Okay. So how do we test this hypothesis? How do we do that? We collect some boys, calculate the mean, collect some girls, calculate the mean, do a difference. Right? So let's see the example we have here is all we do is we just draw some boys here. Right? Some boy here. Okay. How many boys we got is called N1. Right? And what's the average of them is called X1 bar. Right? And we can also calculate the sample variance. Right? Is that clear what we're doing? Right? We are not able to talk to every boy. Right? We talk to N1 of those boys, calculate their mean, calculate the sample variance. Right? And do the same for girls. Right? Look at girls. I cannot talk to every single girl. I talk to some of the girls. How many girls I got? N2 number of girls. What's the average wanted to spend? X2. Right? What's the variance of that? S2 squared. Okay. Now we look at these numbers. Okay. Can it help us to make the judgment? Okay. And how do we do that? Okay. How do we do that? we actually rely on the fact that because they're the bell, difference remain the bell. Okay, the formula is like this. Because they're bell, it means that if I have this, okay, just to slightly little bit, because this is x, all right? X1, any number. One more thing is X1 bar, look like this guy, right? It's still mu1, but now the shape is sigma 1 square over n1, right? Because this is the underlying people. You grab the sample mean, with the shape would be narrowed down, right? Because the more you get, the more squeeze you have, right? The variance go down, the same here, right? And go the same if this is x2, but if we look at the x2 mean, right? This will be same mu2 here, but the shape will be depend on how many data you got. Okay. Now, this is normal. This is normal, right? Difference between two normal, still normal, right? Remember the formula there. Okay. Where locate is mu1 minus mu2, right? And what is the shape? Is sigma 1 square over n1, right? Just add up the variance, right? That's it. Okay. Now, if we know everything, then we're done, right? So this is actually similar to what we have just done, right? The only difference between now and then is because they're same, right? In the previous case, we can come up with some estimation, right? To estimate this better. But now we don't, so we can't do too much, right? The only thing we do is we just use this, right, to estimate this guy. Right? We just keep using this guy or this guy, right? And then we're done. That's it. We do the t value, and that's the same thing. Okay? The t. Okay. The only complication is whether the degree of freedom. Okay. But I'll talk about that immediately. Go to the example. But that is what we see, right? And this is equal, means this is zero, right? Okay, under X now. Okay. And we want to check, right? The idea is very simple, right? Look at the man's average and woman's average, right? If they're very close to each other, then you don't really reject, right? You keep this. If they're very extreme, you reject. So the same idea. There's nothing new here, right? Although we're two variable, you just combine to one, and that one follow the same bell, right? But just the only complication here is the variance is follow this formula. Okay. So the only difference compared to the single case is now the variance a little bit slightly tricky part. Okay, that's the only thing, right? I understand this is very complicated for me the first time to learn. Okay, but that's the best we can do. Okay, let's look at the formula. Hopefully that we are not progressing too fast. Okay. So the only thing is like the same formula here. Okay. The only complication is this particular V here. Okay. And this V actually come from super complicated formula. Okay. What is super complicated? Okay. Let's see. You will be amazed at the formula. Whoa. It's so ugly that I never remember it. Okay. And so don't worry, you ask, okay, who is so crazy to use this? Okay. The good thing is Excel can do all this directly. Okay. So, but here is this. And don't be surprised I asked you for this for calculation for the exam, but you know, you see how we operate, right? Okay. So the same idea here, but let me go to the question. Okay. Go to the example, then you will see how should we proceed. Okay. And the main idea now we have to well, what happened? We have to say we have boys and girls, right? They follow the bell curve. They have different variance. Okay. The question said, now I have boys, 50 boys. Okay. The mean is 40. The sample SD is 4. Okay. And I also have girls. I have 40 girls, right? And they went to pay $42. The on average, and the SD is 3. Okay. We want to see they are same or different. Okay. So that's a question. Okay. So we know from our analysis, we said the following, right? X1 bar minus X2 bar, right? It's a bell curve, right? Under this is 0, right? If they're the same, the sample mean the same, right? If the population mean the same, the sample mean expected to be the same. It's a bell curve, right? And how is the shape of this guy? Very simple, right? Just this, add together, right? Although it's subtraction, the variance add together. Okay, that's a slightly tricky part. The fact, just to me. Right? Now the question is, what we know from the data, the difference between the mean is -2, right? So the question again is, we are here, -2, right? What is this area, right? If we know the sigma 1, sigma 2, yeah, easy, right? It's a bell, right? We know the shape, done, right? Norm dot S dot this, -2, right? Right? Normalize it. Nothing new here, right? The only difference is we don't know this, so we have to go to very complicated problem, okay, which requires to do the t, right? And t is based on something. The rhythm is something very crazy one. Okay, come on, very crazy formula. But let's forget the crazy formula first. The t is this. Okay, this is 0. Okay, and what's 2 here? 2, -2 is you have calculate how to calculate this number. Is the you replace this by S1 and S2, right? So that's what you see. Right? We replace this by 4 squared. This is 3 squared, right? Same. See, right? Because this is variance. You take a square root, right? It's still asking how many SD from this one, right? This is variance, right? You replace the sigma by S, right? This is the estimated variance. You take a square root. We've been doing this all the time, right? Nothing new, right? Nothing new there, right? Turn out to be negative. Then the question again is two-sided test. Look at this area, multiplied by 2. Is it bigger than 0.5? Sorry, 0.05 or more than 0.1? The same thing, right? So you can see there's nothing new here. The only complication is understand what makes the variance, right? Because it's a bell curve and very common to t, right? The same standard thing you have done. Okay. Now, the only thing is, what is the table look? Which t table looking at? It's a V. Okay. This V come from the so complicated formula here. Okay. Look at the complicated formula. You'll be amazed at how crazy it is. But as I told you, if you Excel, just plug in all the thing there. I'm not going to, well, you can check. Okay. But just to remind you what they are. This is S1, right? Because S1 is 4. Okay. And let me go one by one to S2 is 3. So that's how you get this one. Okay. And N1 is 50. So that's how you get this number there. Okay. And N2 is 40. So that's how we get the rest of the number. Okay. So Kind of crazy, I would agree. I mean, of course. But if you have computer, automatic calculate, right? And they tell you this is 87. Okay. Okay. And then the rest is the same, right? Because you know that, we can check it, right? There's a norm this, so on and so forth, right? And the same for interval estimate, right? You calculate that, the denominator put there, same. Okay. It's very mechanical, I would say, right? There's nothing very new there, right? That formula, right? I think I already list out the formula there. But don't worry, you do assignment, then you know. Okay. As I said, if you confused or how to do assignment, please contact TA. He will try to provide as much help as he can without telling the answer, of course. Right? The answer is not going to help you, but I try my best. And is that okay? Now we teach you the other one, which will be the one I try to mention. Okay. This one is very simple, so don't worry. This is super simple. Okay. So don't worry about this. Is super simple. And this is just rewriting, so don't worry. So let me draw a graph, then this one is simple. So it will be something that I think the easiest today. Okay. Now we have the following. So now we want to see if I want to look at how a boy changes if he get a girlfriend. Okay, is it going to have GPA higher or lower? Okay, the question. Okay, a bunch of boys. Okay, here. Okay, now look at the other case. The boy. Okay, now he has a girlfriend. Okay, and the question is, I want to see, right? This is number one, number two, number three here, right? What I want to check is, look at his GPA before he has a girlfriend, now after girlfriend, okay? Whether his GPA goes up. Okay, you don't like this? Okay, go back. Okay? Before he has a girlfriend, now he becomes single. Okay, his GPA go down. Okay, what you like, okay? What you like doesn't really matter, right? So, for the important part is the same guy. Okay, we're looking at how the changes, whether have girlfriend or not, change his GPA. Okay, and we are saying that the changes follow a bell curve. That's our assumption. Let me repeat, which we are assuming that the difference actually follows the bell. That's our assumption. Okay. Of course, you may assume that before is a bell, after is a bell, so it's still a bell. That's fine. Okay. But we're making even simpler assumption. Okay. Just because of guy number one can different, right? Guy number one may be a genius, right? Whether he actually has a girlfriend, no difference, right? Guy number two may be a guy, he is very much into her girlfriend, so he spent all his time and energy with her girlfriend, not studying, right? So it can be different. Okay, so we have to control individual stuff. So that's why we only assume the difference from the pair, right? That's very simple, right? We just look at the difference. There's a one sample test. Very simple. Okay. So let me go to, as I said, this very simple idea. Now, as I said, guy number one, right, is before girlfriend, after girlfriend. Okay. GPA before girlfriend, GPA after girlfriend. Okay. What we care is the difference, right? Where girlfriend make a difference, right? Whether they study together, make them their GPA higher, or they can be go to somewhere to go to KTV, go to Shenzhen, right, to do massage, whatever, right? Then will be go up, go down, depends, right? So what we're saying that is the following, right? The difference, okay, is a variable with k. It's a follow bell curve, right? And you can calculate the mean, calculate the sample variance, right, for difference. Then just the t-test, nothing new here. Okay, nothing new. The same thing. Just the way we interpret data. Just a sample, just a one sample thing, right? So this example is very simple. Okay, let me finish this example, then we call it today. So usually it's a medical test, right? Control group, treatment group, right? In our case is whether the boy has a girlfriend or not, right? You have control group, okay? So what we do is we have 16 people, right? And figure out that the difference is 1, right? So how do you pair? Okay, in our case, right, the example would be saying that the same boy, right, what before he has no girlfriend, now he's a girlfriend, right? But in medical test, how can you do it, right? You can either has medicine or has no medicine. How it exactly done in the real world is you try to have 2 subjects, right? You try to make sure that both of them are very similar. Then you randomly choose a guy that take the medicine, the other take the placebo, right? Then you pair them, right? You try to make sure that the 2 guys actually has similar age, similar medical history, everything is very similar. So you can compare the 2, is meaningful comparison. Is that clear? That's how you pair, right? The same as you do experiment when in high school, right? You do biology experiment, right? You put 2 different plants, very similar, right? And one plant subject to some light, right? Or you give him more water, right? Or change one thing, right? The other plant is very similar, so you don't change, right? And you compare the different. That's the fundamental way you do science, right? You compare and contrast. So this is how you do it, right? And turn out that the average difference is 1. Okay? The sample SD is 2. You want to see whether it's intact or not. Very simple, right? It's a very simple thing, right? How you do it? Right, just to go back to question quickly. Yeah, I still have 1 minute. That's good enough. So, as we said, we assume the D bar under the null is 0, right? There's no difference between the medicine, right? There's no difference between whether the boy has a girlfriend or not. Okay? And turn out that the difference is 1. Okay? So it means that in our case is the boy has a girlfriend actually has higher GPA by 1. Okay? Is it going to be difference by luck or not? Right? Is it 1 sufficiently large enough? Right? This is 1, right? Is it large enough? Again, look at this area, right? If this area is large enough, then yes. Otherwise not, right? So, but we use the T, right? Because we don't know the sigma, right? So let's convert to T here. And then we're done, right? That's become 2. We ask this area multiplied by 2 is more than alpha, right? And turn out that, yeah, we failed to reject in this case, right? It's 6%. So we're saying we can't say whether have girlfriend or not. Actually, change the GPA, right? Maybe same, okay? Then maybe cost and benefit, have a girlfriend, okay? So on and so forth. Is that clear? Okay. So although we haven't done almost thing, but I think next week we'll finish. We can start doing the assignment first. The assignment is due by the end of this month because we have the test on the December 1st, right? So just you can submit them, you can release the answers. Okay. So have a nice weekend. I will see you next week. I stay around to answer any question you may have because I know you will have a lot of questions. So I stay here outside. Okay. See you next week.